Connecting f, f prime, and f double prime through examples. We will start with an algebraic example. Let f of x equal x plus the cosine of 2x on the closed interval 0 to pi over 2. F is smooth and continuous, a nice function on that interval, so there won't be any undefined places or non-differentiable points. Let's find the critical points of f. Are they local maxes, local mins, or neither? Critical points, local max, local min, all of that says let's find f prime of x, which is 1, and then minus 2 sine of 2x. There's a chain rule going on. Since our function is smooth and continuous, we only need to find where f prime is 0 and not where f prime is undefined. That is, we're trying to find where the sine of 2x equals 1/2. So the sine equals 1/2 when the argument, in this case 2x, is pi over 6 or 5 pi over 6, which means x is either pi over 12 or 5 pi over 12, and those are both on our interval 0 to pi over 2. Let's make a sine chart, and I'll stop at pi over 2 and start at 0, so I'll block it off and put f prime here, and then we'll put our critical values, pi over 12 and 5 pi over 12, and plug in values into f prime. So we can actually use 0 and pi over 2, even though they're at the endpoints, to help us get the signs. So if I find f prime of 0, I get 1 minus 2 times the sine of 0, or 1, which is positive. If I plug in a value in between pi over 12 and 5 pi over 12, let's say pi over 4, that goes inside there. If I find, write it here, f prime of pi over 4, I get 1 minus 2 times the sine of pi over 2, which is 2 times 1, or 1 minus 2, because the sine of pi over 2 is 1, so I get negative. And finally over here, if I did a similar thing, I would get positive. So if I draw f, increasing, decreasing, increasing, I see that f has a local maximum at x equals pi over 12, and f has a local minimum at 5 pi over 12. If you need to stop and take a little more time to plug in your trig special values into f prime, feel free to do so. If you're ready, let's find the inflection points of f of x on that interval. Inflection points is a keyword or phrase that says let's look at f double prime, either where f prime changes increasing to decreasing or vice versa, or more often where f double prime equals 0 and changes signs. So if I find the second derivative, I get negative 4, don't forget the chain out, cosine of 2x. Nice smooth function, put where it equals 0. So I'm trying to find where the cosine of 2x equals 0, or where the argument 2x is, let's see, pi over 2. It could be 3 pi over 2. Let's see what happens. Where x is pi over 4, or 3 pi over 4, but 3 pi over 4 is outside of my interval 0 to pi over 2. So we only need to check x equals pi over 4, and what we're trying to see is, does f double prime change signs at x equals pi over 4? And if I plug in values in the second derivative, I try, say, x equals 0, I get negative 4 times the cosine of 0, negative 4 times 1, which is negative. If I plug in, say, something bigger, say pi over 2, I get -4 times the cosine of pi, -4 times -1, or positive. And f double prime does change signs, so there is an inflection point at x equals pi over 4. Let's do one with a table. Consider the table with the values of g, g prime, and g double prime. And let's draw a graph of g of x. How should we start? I think I should start by plotting the actual points of g that I know. So I know that g of 0 is 3, g of 1 is 1, g of 3 is 2, and then g of 5 is back up to 3. Now, how can I connect these dots? Well, I'm going to connect these dots by looking at a combination of g prime and g double prime. So on the first interval, 0 to 1, since g prime is negative, I know that g is decreasing. G double prime positive means g is concave up. So I could draw that part decreasing and concave up like that. On the next interval, g prime positive means g is increasing. G double prime positive means g is concave up. So I'm going to draw g increasing and concave up. On my final interval, g prime positive means g is increasing. G double prime negative means g is concave down. So I'm going to draw increasing but concave down, like that. And that would be a rough sketch of g of x. To reiterate, when I'm connecting dots, notice how we use a combination of g prime, increasing or decreasing, and g double prime, concave up or concave down, to draw those pieces. I have one last problem for you. It's going to be a table of data with some questions. Here's how I would like you to approach this. Copy this down or whatever you need, and then I would like you to answer all of these questions A through I, based on the table, where f, f prime, and f double prime are continuously differentiable for all x. The answer to A through I is true, false, or cannot determine. And I would like you to also give a reason for your answer. So try this, turn the video off, and we have all the answers. Turn the video back on, and in just a bit I will scroll down and put the answers that I have for you. Do your answers match mine?